So yes, I'm Fred Radford, entrepreneur and founder of Beyond Earth. And what we do is we build rockets that allow you to launch your satellite into orbit effectively for zero cost. Our customer profile is around NASA and SRI, Hawkeye 360, and of course CubeSat companies. And we already have 7 letters of interest for our rocket launch system. The team is built up kind of like what we just heard about from Michael around aerospace entrepreneurs that are really focused on the timing and when is it the right time to be able to produce these kinds of features. And so, for example, I've been launching rockets for 20 years, and Gary owns a solid rocket manufacturing company. The problem that we're addressing is that there's a huge amount of lost time to market revenue because after a satellite is completed, it can take 12 to 18 months before it's actually launched and you start producing revenue from it. And for research missions, this isn't such a big deal. But now that we're seeing all these entrepreneurs creating commercial satellite companies, getting a return on your investment is much more important. And you see the cost per kilogram coming down for the large missions, but it hasn't started to come down quite as much for the microsatellites yet. In fact, most rideshare missions are still costing around $30,000 a kilogram. So what we need to do is work on getting that down as well. And our solution is a customer-focused, dedicated, on-demand launch as a service for microsatellites. Basically, the launch can be free. By launching 4 to 12 months earlier than a rideshare mission, it can pay for itself in time to market revenue. It also has the advantage of having custom orbits, no coordination with other payloads, and a total cost of under $1 million. We do this with an on-demand solution with ready-to-fly rockets, little notice, as low as 24 hours, and you can change the launch window whenever you want. Our secret sauce is the intersection between this low cost, the on-demand nature, and being able to focus on dedicated missions. Our business model is similar to NetJets, where we have a reservation of 10% to get the nose cone and start the integration, which can happen months and months before the launch. And then you pay the balance, 90%, when you're ready to do the launch. Because of this, we actually are projecting revenue prior to orbital launch of 2022 revenue of just over $1 million by selling the payload modules. We're formed in 2018. We have 7 letters of interest. We just finished the preliminary design on our first vehicle, which is designed to send 30 kilograms to 400 kilometers sun-synchronous orbit, and we're ready to start manufacturing. When we analyze the market, everyone knows it's very large. We did a bottoms-up estimate for the 30 kilogram market by 2028, found that 75% of satellites by quantity will be in that range, and we estimate about $1.4 billion in serviceable attainable market for 2028. Obviously, there's competition. This chart is showing that we're on from left to right on the dedicated side, and from bottom to top on the fast response 24-hour turnaround time. So SpaceX is great if you need to send a school bus up, but not so great if you need to do something quickly. We're raising a $2 million seed round for the next 12 months. The proceeds will be used for creating the first vehicle prototype, doing regulatory approval, and getting our launch and ground systems operational. Thank you.
All right, thank you, Fred. First question comes from Tori. Hey, Tori. Fred, I would love to launch a small enclosure with one of our pill robots to test the propulsion system in a weightless environment. What would that process and time frame look like if you were to use your company?
Right. So we are at the beginning of the development phase. We will not have an orbital launch until 2023, 2024, which from a hardware standpoint or software standpoint sounds like it's a long time, but from a rocket company, it's about 1/4 the amount of time it normally takes, because we are using existing technologies and building on getting to orbit and not necessarily reinventing things or creating new engines and things like that. For your pill robot specifically, we do have space validation as a new market that we're exploring and like ramping up. So if there's a value in being able to do something this week for $1 million, then we're the best solution for that. Again, it would be 2023 timeframe. The other thing is that if you have other organizations that want to do space validation, you can get together and build the payload module out any way you want and put it together. But for some of these really larger missions that are in the hundreds of millions or billions of dollars, being able to do a space validation in a week for only $1 million is a really good value proposition. I'm not sure how it fits in with your robot validation.
Yeah. And Tori, in addition to that, through the Advanced Tech Accelerator, we can connect you with the International Space Station, where they do these types of experiments on the International Space Station all the time, and they can help do it for free. So let's connect offline on that, because I know that's it's an area of interest for you.
Yeah, especially if you have the time, they can do it almost for free. Yeah, it's very, very cost effective.
Yeah. So David asks, is there money to be made from the pre and in mission data sets produced from the launch?
For the launch vehicle itself, not so much. I mean, there's a little bit that can be used primarily for defense, from analysis of the launch profiles and the trajectories and things like that. Really, most of the data, most of the value is really coming from the satellites that are in orbit. And what we're trying to do is make innovation happen in orbit a lot quicker, on the order of months instead of years. So we're kind of selling the shovels, not necessarily saying that we're going to be selling the data. In fact, if you look at the FAA's market for the space economy, last year it was $355 billion. Launch was only $6 billion of that. And that's because if you can launch something for $1 billion, you'll actually get $15 billion back in revenue from cell phones and television and all the geospatial data. So really, that's where the return on investment for the satellite companies is from a data standpoint, not necessarily on the launch vehicle, but much more on the communications and the imaging that the satellites are providing.
That's great. Andres asked, can you clarify how the launch is free? So in the very beginning, you had the launch for free.
Yeah, so here's the current problem is that you build a satellite and it takes you X number of months, let's say 9 months to build a satellite. And oftentimes the first thing you do when you start building a satellite is contact a launch provider and say, how many amps do I need at 28 volts? What kind of payload adapter? What FAA or FCC frequencies am I allowed to use? Because you have to start doing all this negotiation way in advance. But even after you get all that done and you're spending all that extra time that's not on your product, you get your satellite finished and it has to go for integration. After it's all been tested, it has to go for integration and waiting, and the prime payload might get delayed. And so all of this is putting a time frame in where there is the schedule that is between 12 and 18 months on average. Bryce just released a study, I think 2 days ago, 3 days ago, that the average delay for the small satellites, this is not even the scheduled, is 128 days. So if you take the schedule of having a delay of 4 to 6 months and an average delay of another 128 days, you see that what's happening is that there's this hidden cost that no one is tracking. Because in a research project, if it goes up this year, next year, or the year after, it really doesn't matter. When you're trying to make revenue off of your small satellite and you're going to expect $100,000 a month or $250,000 a month, every month that you're not in space and generating revenue, you're losing money. So if you're making $250,000 a month and you get up only 4 months sooner, you've just paid for the launch. It's effectively free. And if we get you up 8 months sooner, we actually made you $1 million. And if we get you up 12 months sooner, now you're $2 million ahead of the game. And in this environment where you have trying to reduce the risk of startups, being able to get time to revenue is very important. I hope that answers the question.
Great. Alex asks, where are you planning on launching from, and how does this reflect your margins?
Right. So we're a mobile launch vehicle that can be launched with a team of 5 people. So the pandemic of people having 10 or more groups doesn't affect us. We can actually still keep launching. The entire system fits in a 40-foot shipping container and can be taken anywhere in the world and launched from any place that we have permission from. Being a U.S. company, we need FAA permission, and there's 38 spaceports that would qualify for this. Initially, our launch location will be Wallops. They're very well known for knowing how to launch a large quantity. They launched 16,000 sounding rockets, and we're very small. We're doing 30 kilograms, so we're just about twice as big as a sounding rocket. But also, Alaska and in Southern California at St. Nicholas Island will be the initial launch locations. But we can launch in New Zealand, the new Brazilian site, all these places, because we don't really need any infrastructure. We can show up and within a matter of days be ready to launch.
Great. One final question here, and then we'll move on to Aaron. If it's launch on demand as a service, how long does one rocket take to build, or do you have a stock of rockets ready to launch?
Right, and that's part of what I was talking about with the secret sauce of being on demand. Most of the time, when you buy aerospace equipment, whether it's a jet or a rocket, you sign a contract and then the company starts building it. Uh, because we have founders that understand how to build commercial solid rockets and vehicles in advance, we're really taking it and flipping it on its head. So it's much more of a going to a Toyota dealership and picking out a car that's already assembled. By doing this, you won't be paying for something that's built far in advance. The reason we can build these in advance and have them staged and stand by is that they are small and they're much less expensive than having to build this huge infrastructure out there. The idea is that by having 10, 15, 20 at each of the launch sites, whoever needs to launch can launch on very short notice and pick whichever one's available. It doesn't have to be a named vehicle anymore. It can just be whichever vehicle is available to you. And that's kind of how we're kind of changing the game by being able to pre-build these rockets in advance.
All right. Thank you, Fred. Great pitch.